Alright, so let's finish up this from the review. Now, this might be the same as some, but we did add a few. So remember, f of 0, the 0 is the input. We go up to function f, which is right there. Its output is 6. G of 3, our input is 3. Go on our graph G up here. The output is 2. Now, when it's g of x equals, we're doing the opposite. So we go up to 1, over to, on the y-axis, go to the function, then down. What's the x value? 2. F of x equals 7, so that's the output equals 7. So I go up to 7, then over to f of x. What's our input? Negative 2. So now, where is f of x equal to g of x? So where do they intersect? Right here, at 4, 4. That's a point, right? Now the last two, we're adding and subtracting our functions. So we're just taking the information, we're going to add or subtract it. So first we find out they've got the same input, so at 2. Our output is 1 for g of x, and for f of x it's 5. So what's 5 plus 1? That gives us 6. Okay, now negative 2. Negative 2 up to f is 7. Right? Goes back to that one. Minus g of 4. 4 is right here, up to g. That y value is 4, so 7 minus 4 gives us 3. Okay, now we're going to kind of do the same thing, but with the story problem. So Hope has been tracking the progress of her family as they travel across the country during their vacation, and she has created a function d of t equals 78 times t to model the progress they are making. So what is she trying to do if she writes d of 4 equals 78 times 4? Well, 4 stands for the time, right? So in 4 days, we'll say, she wants to know how far. So she's looking for how far they travel in 4 days. Okay, B, what would d of t equals 450? So that's the output, so it means they traveled 450 miles maybe. Okay, what would d of 3.5 mean? It would mean, 3.5 hours, and most likely we'd figure out how far. Okay, the last one, how could Hope use this function to find the time it would take to travel 800 miles? So d of t would equal 800 miles, right? This is our formula, so replace the d of t with 800 and then solve. So divide by 78, so we'd get the time equals whatever that is, which ends up being about 10.25. Okay, it's a longer decimal, but about 10.25. Alright, now this last one is we're actually going backwards. Instead of given a function and creating the key features, we are given some key features and creating our function. So first, let's deal with the points. So here's a point, here's a point. So at 0, 2, there's my y-intercept, so I can draw that. 4, negative 2 is my minimum, so that's the lowest my function goes. Now, my domain. My domain tells us where we start and where we end. So my leftmost point is going to be negative 5. So that's where it starts, somewhere on this line here. But remember, since that's my lowest point, we can't start lower than that. And it goes till infinity, so it's going to keep going to the right. Okay, we also know it's increasing from 4 to infinity. So at this point 4 here, it's going to start increasing. So somehow it's going up and just keeps going. Okay, so now over here I can start up high, start down close to low, anywhere in this area up and back down. Maybe that could be a maximum as well. I could start up here and go down. As long as I go through this point and this is my minimum, okay, and it's a function so I don't go any crazy stuff, we can do it pretty much any way. So maybe I'd go like this. It curves down, hits that, comes up, back down, and then goes up. And I'll draw that as a point. Which actually I need to continue to 5, so I should probably go to that point. Something like that. Your function may look totally different, as long as it's got that same information. There we go. So that's the rest of the review. Make sure you watch the other video to go along with it.